Hi guys, welcome back to Mathematics for Engineering 3 international programs at Ksesa University. Today we're going to be looking at the non-homogeneous higher order differential equations. Okay, but unlike in the previous video when we studied the the undetermined coefficients approach, right, in order to solve the non-homogeneous higher ordered equations, right, when Rx is not zero, right? First we looked at y as y is the sum of yc and yp, right? And we get yc when we assume that r is zero, and then we guess the form of yp, right? We guess the form of yp. After that we need to compute y prime, y double prime, y triple prime, right? Oh sorry, before that we need to see whether or not the terms in yp are the same as the term in yc. If they are, we need to multiply yp by x to the n, right? Okay, until they aren't the same. Okay, after that we need to find yp prime, yp double prime, yp triple prime. Okay, and substitute that back into the equation, and then we find the coefficients, right? a1, a2, a3, and a4, blah blah blah. After that we receive the solution, which is yc plus yp. Okay, but in this video we're gonna be looking at a different approach called variation of parameters. Okay, I think it's a little bit easier, okay, because as you say in the previous video when we were trying to determine the value of coefficients, right, the a1, a2, a3, they are really messy, right? It's so messy. There's a lot of things going on. They are not hard, it's just so messy. But this approach is going to be a little easier. Okay, let's take a look at the approach. Okay, first consider second order equations. Okay, we're going to be looking at the second order equations first. Okay, so this is the second order equation when Rx is not zero, which means that this equation is a non-homogeneous differential equation. Okay, and p, q, r are functions of x. Okay, so first we know that yc is c1 y1 plus c2 y2. Why? Because this is the second order, right? It's actually the second order, which means that you have two roots, right? You have two roots. You definitely have two roots for the second order equation, which means that you definitely have y1 and y2. Okay, that's why yc can be written as c1 y1 plus c2 y2. Okay, for example, if you look at, I don't know, m squared plus 2m plus 1 equals 0, we want to find yc, right? So we take r as 0, and then we have 2m. Okay, and this y1 and y2, they might be e to the x, e to the, I don't know, 2x, or they can be repeated roots, they can be complex roots. Okay, so let yc in this term be the solution of this when it's homogeneous. Okay, and then assume that the general solution is y equals a1 y1 plus a2 y2. Okay, guys, this is not yp. Okay, this is the solution. And a1 and a2, they are not constants. They are function. They are function of x. Okay, so they aren't parameters, they aren't constants, they are functions of x. Okay, so we let assume that, okay, we don't know whether or not they are right, but let's assume that the solution, the general solution, can be written as a1 y1 plus a2 y2. Okay, they're not yp. Okay, we have no yp in this section. Okay, yp would be for the previous section, which is the undetermined coefficients. Okay, so we have that y prime is, what is it? It would be a prime 1 y plus y plus a1 y prime plus a2 prime y2 plus a2 y2 prime. Okay, guys, because a1 and a2 are function of x. Okay, so if you want to differentiate this function, okay, you want to find the derivative of this function, you need to have u dv plus v du, right? That's why you have u dv plus v du. Okay, so here it needs to be y1 y1 y2 y2. Okay, and let's assume that a1 prime y1 plus a2 prime y2 is 0. That is the assumption. Okay, so it might not be true. Okay, we just assume and see whether or not things go well. Okay, so we just assume. Okay, so if they are 0, it means that this guy is 0, this guy is 0 as well, which means that y prime is actually this guy. Okay, in that case, y double prime, what is y double prime? Y double prime would be a1 y1 double prime plus plus a1 prime y1 prime plus a2 y2 double prime plus a2 prime y2 prime. Okay, again, guys, we apply the product, the derivative of product, okay, which is u dv plus v du. Okay, and in that case I can write it as a1 a1 y1 double prime plus a2 y2 double prime plus a prime y1 prime plus a2 prime y2 prime. Okay, I just rearrange the term. Just keep this term here, put this term over here, put this term here, and keep this term here. Okay, just rearrange the term. Okay, and then we substitute y prime, y, and y double prime into this equation. Okay, so what we have is, what is it? Y double prime, which is a y1 double prime, sorry, a1 y1 double prime plus a2 y2 double prime plus a1 prime y1 prime plus a2 prime y2 prime. Okay, that is y double prime. And then we have plus p, and then we have y prime, which is a1 y1 prime plus a2 y2 prime, and then we have it equals r, right? Oh no, we have qy first, so we have plus q, and y is a1 y1 plus a2 y2. Okay, that equals r. Make sense? Makes sense. We just, we basically substitute y prime and y double prime in this equation. Okay, we put y prime in there, we put y double prime in there, we put y prime in there, and we put y in there. Okay, so this is what we have after substitution. Okay, so I rearrange the term a bit. Okay, so I have a1 y1 double prime plus p y1 prime plus q y1. Okay, can you see that? Can you see that? Why? Because if you look here, a1 y1 double prime is actually this term. Okay, and then you have a1 y1 a1 y1 prime b p, which is this guy. Okay, and then I have a1 q y1, which is this guy. Okay, okay. The next term is plus a2 y2 double prime plus p y2 prime plus q y2. Where does it come from? It's from here, a2 y double prime. See, a2 y double prime, and then we have a2p y2 prime, which is a2p y2 prime. It's actually this term. Okay, so we get exactly the same term. And the last term is a2 p and a2 q and y2, which is a2 q and y2. Okay, okay, and that equals r. Okay, oops, sorry, we have the other two terms, remaining two terms. So we have a prime y1 prime plus b prime y2 sorry, a1 prime y1 prime a2 prime y2 prime equals r. Okay, because these are the remaining. Okay, it's this term and this term. Okay, it's the remainings. But guys, y1 and y2, they are solution of this, right? Right? y1 and y2, they are solutions of the homogeneous equation, right? It means that this guy is 0 and this guy is 0 as well. Okay, okay, so what I have is this guy equals r. Okay, which is the remaining term here. Okay, so we can find a prime y prime by this equation. Okay, from equation equation 1 here. Okay, I'm just gonna copy it to the next page. Okay, so that you can observe easily. I'll put it somewhere here. Maybe make it a little smaller. Maybe here. So as you can see, we have two equation. Okay, okay, and that correspond to this matrix. Okay, why? Because here we have y1 times a1 prime, y2 times b2 prime. Okay, y1 a1 prime plus y2 a2 prime equals 0, which is this equation. Okay, you multiply the matrix. Okay, okay, and after that you multiply this row to this column. Okay, you get y1 prime a1 prime plus y2 prime a2 prime equals r, which is this equation. Okay, so we can solve for a1 prime by using Kramer, right? Which is you basically you put this to the first column. Okay, you substitute the first column with 0 and r. So this is what you have is 0 and r, y2 prime. Okay, this is the determinant of this. Okay, is what we call Kramer's rule. Okay, I already taught you in the in one of the lecture. Okay, in one of the videos. Okay, so basically you just substitute the first column by this one, and then you can find a1 prime. And similarly, if you want to find a2 prime, you substitute 0 and r to the second column, and this is y1 prime. So we can find a1, which is, what is it? What is a1? a1 is going to be minus I don't know, minus y2, okay, divided by this determinant y1 y2 y1 prime y2 prime. Okay, I'm not gonna, okay, we can do that, but you know, I really don't want to. I'm just gonna leave it like that. Okay, and the other one we have y1r divided by this determinant y1 y2 y1 prime y2 prime. Okay, oops, sorry, this is a1, my bad, this is a1. You only have a1 prime, so a1 is actually integrate of a1 prime dx plus c1, and this is integrate of a2 prime dx plus c2. And why the solution is, what is it? We assume that is a1 y1 plus a2 y2. Okay, so let me go through what we have done again. First, you know, we look at the homogeneous case. We have yc, which is in this term. Okay, we have y1 and y2. After that we assume that the solution can be written in this way when a1 and a2 are functions of x. Okay, this is important, they are functions of x. After that, we investigate the first derivative and the second derivative. Okay, we make this assumption, and then we put the first derivative, the second derivative, and y into this equation. Okay, after that, you know, after some rearranging, we get this equation. So once we have two equations, we can write it in the matrix form. Okay, it's a system of linear equations. Okay, and in that case, okay, we have this one equation, these two equations, and then we can write both of them in terms of matrix. Okay, and from Kramer's rule, we can find a1 prime using this approach and a2 prime using this approach. Okay, and once we have a1 prime and a2 prime, we can find a1 and a2 by just integrate a1 prime by x plus c. Don't forget, guys, a1 is a function of x and a2 is a function of x as well, and the solution will be a1 y1 plus a2 y2. It's a bit abstract, guys, it's a little bit abstract. Okay, it's hard to understand, but once you see the exercise, okay, you see the examples, it will become much clearer. Okay, and this approach can be extended to higher order equations. Okay, for example, this is equation of order n. So the solution is c1 y1 plus c2 y2 plus c3 y3. Oops, sorry, this is not the solution. The solution is actually a1 y1 plus a2 y2 plus a3 y3 plus blah 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 plus an yn. When the y's, y1 to yn are solutions of the homogeneous case. Okay, and a1 a2 a3 to an are functions of x. Okay, and after that, if we repeat the same process, we will come up with these system of linear equations, okay, which can be written as this matrix. Okay, which can be written as this matrix. And in that case, we can use Kramer's rule, right, again, to find each a's. Okay, we can find each a. Okay, and once we have each a prime, to find each a prime, and once we have each a prime, we can find a by integrate each a prime, right? After that, we get the solution, because the solution is in terms of a. Okay, guys, this is just an idea. Okay, you don't need to completely understand it. Okay, because you will have the take-home message. You have the take-home message. Okay, the take-home message is that if you want to solve this equation, first you find y1 y2 y3 to yn, and by assume that this is 0. Okay, and in that case, you go back to the homogeneous linear equations, right? You have the characteristic equation, right? Solve for the roots and blah blah blah. After that, we write down the equation, the solution as this. Okay, when a1 a2 a3 to an are functions of x. Okay, after that, we have the system of equations, and this system of equation is quite easy to memorize. Why? Because it looks like that: y1 y2 to yn, y1 prime y2 prime to yn prime. Okay, y1 double prime y2 double prime yn minus 1 double prime to yn double prime, to y1 derivative of y1, the nth derivative of y1, the nth derivative of y2, nth derivative of yn minus 1, and nth derivative of yn. This is, if you remember, this is actually the Wronskian. If you remember, it's actually Wronskian. Okay, and this guy is 0 0 0 0 all the way, and the last component is r. Okay, and all these guys here are a primes. Okay, so you can use Kramer's rule to get each a prime. After that, you can find a by integrate each a plus c. Okay, after that, you obtain the solution. Okay, which is a1 y1. I should have 1 here. a1 y1 plus a2 y2 blah blah blah. Okay, this is the take-home message. This is what you really need to memorize. Okay, see, I've been trying to give you the idea. Okay, give you the idea how to solve the equation. Okay, it came from, you assume something, you get a system of equations, blah blah blah. After that, I gave you the take-home message. Okay, these are the steps to help you to solve the non-homogeneous equation using the variation of parameters. Okay, and after that, we're gonna be looking at the example. Okay, if you want to look at this example, first we need to find each y, right? First we need to find each y. So I look at y double prime minus 3y prime plus 2y equals 0. Okay, okay. And in that case, we have that is m squared minus 3m plus 2 equals 0. Factorize it. We have m 2 1 minus equals 0. M is 1 and 2. So y1 is e to the x, y2 is e to the 2x. Okay, and that is y1 and y2. Okay, secondly, we have that the solution y is a1x plus a2x. Don't forget, guys, we have only two terms because this is the second order. Okay, sorry, a1y1 plus a2y2. Okay, okay. In that case, the next step, the third step is to write down the system of equations, right? System of linear equations in terms of metrics. So the first step, we have this matrix, which is e to the x, e to the 2x. Okay, guys, this is y1. This is y2. Okay, and this one is y1 prime, y2 prime, right? So I differentiate y1, which is e to the x, to e to the 2x. And then I have a1 prime, a2 prime. I have here 0 and r. But our r here is 1 plus e to the minus x minus 1. See? It's as simple as that. Make sense? Make sense? Then we're gonna be solving for a1. A1 would be the, we put 0, 1 plus e to the minus x. We use Kramer's rule, right? To the power of minus 1. And we have e to the 2x, 2e to the 2x divided by the determinant of e to the x, e to the 2x, e to the x, 2e to the 2x. And that is, what is it? Minus e to the 2x, 1 plus e to the minus x minus 1. Okay, divided by 2e to the 3x minus e to the 3x, which is minus e to the 2x, 1 plus e to the minus x minus 1 divided by e to the 3x. Okay, basically I just compute determinant. Okay, okay, and here it cancel out, we have e to the x. Okay, so we basically have minus e to the minus x, 1 plus e to the minus x to the power of minus 1. That is a1 prime, sorry, it's a1 prime. It's not a1, it's a1 prime. Okay, 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 okay. And so we have a1 is actually integrate of minus e to the x, 1 plus e to the minus x minus 1 dx plus c. Okay, that is a1, right? We integrate a1 prime, basically. Okay, okay, okay. And to integrate that is actually integrate of 1 plus 1 over 1 plus e to the minus x d of 1 plus e to the minus x plus c. Make sense? Make sense? This guy, I flip it down here. Okay, and d of 1 plus e to the minus x is actually minus e to the minus x. We have minus here, minus e to the minus x. So we have that a1 is actually log of 1 plus e to the minus x plus c. Okay. And then we need to find a2. Okay, we need to find a2. a2 is, similarly, a2 prime would be the determinant, which is e to the x 0 and 1 plus e to the minus x minus 1 divided by this guy, right, which is this guy, right, which is e to the 3x, right? Makes sense? This guy, they are the same, right? So it's e to the 3x. Okay, and that is e to the x 1 plus e to the minus x minus 1 divided by e to the 3x. So we have this cancel out, we have e to the 2x. So we have e to the minus 2x 1 plus e to the minus x minus 1. Okay, and that is a2 prime. Okay, so if you want to get a2, we need to integrate that function. Okay, we need to integrate that function, but the problem is how. Okay, guys, let's look here. Is e to the minus 2x divided by 1 plus e to the minus x. Okay, and we have that a2 is actually integrate this guy plus c2. Okay, I'll call this c1. Okay, and here I have c2. But guys, how to integrate this function? Okay, for some of you who don't know, you probably need to brush up your integration technique. Okay, so a plus e to the minus x minus e to the minus x divided by 1 plus e to the minus x dx plus c2. Okay, in that case I have integrate e to the minus 2x plus e to the minus x divided by 1 plus e to the minus x dx minus integrate e to the minus x divided by 1 plus e to the minus x dx plus c2, and that is integrate e to the minus x plus 1 dx divided by 1 plus e to the minus x minus integrate e to the minus x divided by 1 plus e to the minus x dx plus c2, and this guy cancel out. Okay, integrate of e to the minus x dx is actually integrate of e to the minus x d minus x, and you need to have another minus here, right? The second integral becomes 1 over 1 plus e to the minus x d of 1 plus e to the minus x, but d of 1 plus e to the minus x is minus e to the minus x. Okay, so the minus disappeared, plus c2. So here we have minus e to the minus x. Okay, minus e to the minus x plus log of 1 plus e to the minus x plus c2. So the solution y is a1 y1 plus a2 y2, which is, what is it? y1 is, a1 is log of 1 plus e to the minus x plus c1, and y1 is e to the x plus y2, which is minus e to the x minus x plus log of 1 plus e to the minus x plus c2. Y2 is e to the 2x, and that's it. Okay, and that is the solution. Okay, is it hard? Okay, let me do some recap. First, we begin with the homogeneous equation, right? We solve the characteristic equation. We receive the y1 and y2. After that, we know that the solution is written in this form when a1 and a2 are the functions of x. After that, we can write down the system of linear equation. Okay, this is y1, right? It's y1, y2, y1 prime, y2 prime, right? So what we have is e to the x, e to the 2x, and then derivative e to the x, e to the x. Derivative of e to the 2x is 2e to the 2x. And you have a1 prime, a2 prime here. And here is 0 and r, right? If you remember from the take-home message. And r is here. We just put it there. After that, we use Kramer's rule to compute a1 prime. Okay, so basically we put this column into this column. Okay, like that. See, and this remain the same. See, this remain the same. We just put this column to this column. Okay, and down here it's just the determinant of this, which is actually the Wronskian. Okay, so we can compute a1 prime. After that, we integrate a1 prime, so we get a1, right, which is this one. And similarly, we do the same for a2 prime, right? We substitute the second column with 0 and r. Okay, and then down here is pretty much the same as that, which is, we already computed it. It's e to the 3x. So we have e to the 3x here. After that, we receive, a2 prime. So we integrate a2 prime plus c, so we get a2. Okay, and this is the a2. So the solution is a1 y1 plus a2 y2, which is this form. Okay, is it too hard? I hope it isn't. Okay, guys, let's look at this example. If you look here, the coefficient of y, the second derivative of y is 2. Okay, it's 2. But if you look at the take-home message, the coefficient here need to be 1. Okay, let's note it here. Note the coefficient of yn. Okay, the first y to the left hand side, it needs to be 1. Okay, so the first thing you need to do for this question is that you need to change it to y double prime plus y equals 1/2 of sec x tan squared x. That is the first thing you need to do. Okay, if you don't do this, it's gonna be a really huge mistake because you're gonna be spending lots of time solving it. Okay, but without doing what you should have done first. Okay, after that, we get back to our steps. First, we look at y double prime plus y equals 0, which means that we have m squared plus 1 equals 0, which means that m is plus or minus I. Okay, so we have that y1 is actually psi x. Okay, and okay, let's use cos x first. Cos x, and y2 is actually psi x. Okay, it should be e to the ax cos x and e to the ax psi x, right? Psi bx, right? But a is 0, so this is 1, this is 1, so we only have cos and psi here. That's the reason. Okay, okay. Next, we know that y is actually a1 y1 plus a2 y2. Okay, and third, we have the system of linear equations, which is, what is it? Cos x, psi x. The relative of cos is minus psi x and cos x. So we have a1, a2 prime prime equals 0 and 1/2 sec x tan squared x. Okay, okay. Okay. Next, we find the value of a1 prime. A1 prime would be by Kramer's rule, right? We have a1 prime as 0, 1/2 sec x tan squared x psi x cos x divided by cos x psi x minus psi x cos x, and that is minus 1/2 sec x tan squared x psi x divided by, here is cos squared x plus psi squared x. But guys, cos squared plus psi squared is always 1, right? It is always 1. So a prime is actually minus 1/2. Sec is actually 1 over cos x, right? Tan squared x psi x. But guys, psi over cos, that is tan. So we have that is minus 1/2 of tan cubed x. Okay, okay. So a1 is integrate minus 1/2 of tan cubed x dx. Okay, I'm not going to be integrating. Okay, if you don't know how to integrate this function, you can let me know. Okay, we can talk about that in the live class. Okay, we can talk about that in the live class. So just let me know if you don't know how to integrate tan cubed. Okay, and the answer is minus 1/4 of tan squared x plus 1/2 of log of sec x plus c1. Okay, I'm not going to be computing. Okay, I'm just gonna show you the solution. If you don't know how to integrate this guy, just let me know. Okay, okay. And similarly, guys, a2, what is it? A2 prime is the determinant of cos x minus psi x, and here is 0, 1/2 sec x tan squared x divided by 1, right? Right, because it's divided by the same term, which is 1 here. Okay, and we have that a2 prime is 1/2 cos x sec x tan squared x. But guys, sec is 1 over cos, right? So this cancel out. So we have 1/2 of tan squared x. Okay, okay. So we have that a2 is actually integrate of 1/2 of tan squared x dx plus c2, and integrate of tan squared is 1/2 of tan squared x minus x plus c. Again guys, if you don't know how to integrate tan squared, let me know, okay? We can talk about that. Okay, I can tell you, I can. Okay, no, I'm not gonna talk about that. Okay, I can tell you a little bit. Tan squared is actually sec squared minus 1. Tan squared is actually sec squared minus 1. So you change tan squared to sec squared minus 1, and then you integrate it accordingly. Okay. So what you have is, no, it's not tan squared. You have just tan here. My bad. You have tan x minus x plus c. So the solution y is actually a1 y1 plus a2 y2, and a1 is minus 1/4 of tan squared x plus 1/2 of log sec x plus c. y1 is cos x plus a2, which is 1/2 of tan x minus x plus c2. Let's say this is c2 and this is c1. Psi x, and that's it. Okay, and that is a solution of the non-homogeneous linear equations of second order. Okay. The last example is when we have the third order. Okay guys, here the coefficient here is 1 already, so you don't need to you don't need to be you don't need to change the coefficient of y triple prime. So first, first we look at y triple prime plus 2 y double prime minus 3y prime equals 0, which means that we have m cubed plus 2m squared minus 3m equals 0. We pull 1m out, we have m squared plus 2m minus 3 equals 0. We have m 3 1, we have plus and we have minus here, which is 0, and we have m equals 0 1 and minus 3. Okay, 0 1 and minus 3. So we have that y1 is e to the 0x, which is just 1, right? Y2 is e to the x, and y3 is e to the minus 3x. Okay. Second, we know that y is actually a1 y1 plus a2 y2. In this case, you need to plus a3 y3. Okay, we have 3 y's. Okay, and third, we have the system of linear equation, which is, what is it? It is y1, which is 1, y2 e to the x, y3 e to the minus 3x, and then derivative of y1 0 0, e to the x minus 3 e to the minus 3x, 9 e to the minus 3x, and we have a1 prime, a2 prime, a3 prime equals 0 0 120 x squared e to the 2x. Okay, this guy is actually r. Okay, is that cool? Can we just follow the steps? Okay, after that we have we need to compute a1 prime, right? a1 prime would be the 0 0 1 2 0 x squared e to the 2x e to the x e to the x e to the x e to the minus 3x minus 3 e to the minus 3x 9 e to the minus 3x divided by here, which is 1 e to the x e to the x e to the minus 3x 0 0 e to the x e to the x minus 3 e to the minus 3x 9 e to the minus 3x. Okay, and then you compute the determinants, the two determinants. Okay, here, as you know, here is 0, here is not 0. Okay, let's compute each of them separately. So we have y1 a1 prime equals here it would be, what is it, 0. Here we have 120 times 3 360. So we have minus 360 x squared e to the 2x and e to the x. Okay, let me do it slowly. I'll just copy this to the next page to see. Otherwise it might be confusing to you guys. Okay, I'll just keep it there. Okay, I'll do it again. Here, this one is 0. Okay, this one, it need to meet this one, right? Because basically you need to put this column here, right? So when you get this you get this, which is this term. Okay, so you get minus e to the x 3 e to the minus 3x and then 120 x squared e to the 2x. Okay, after that this term, it need to meet this term, and this term is 0. Okay, so it is this term, which is minus 120 x squared e to the 2x e to the x e to the minus 3x. Okay, divided by here you have, what is it, 9 e to the x e to the minus 3x. Okay, and this one, and this one is 0. This one is 0 as well. So you have this one 0, this one is plus e to the x 3 e to the minus 3x and 1. So we have a1 equals what is it, 480, right? Minus 480 e to the minus 2x e to the minus 2x x squared divided by 12 e to the minus 2x. Okay, which is minus 40 x squared e to the 2x. Okay, and guys, a2 prime would be this guy. What is it? 1 0 0 1 0 0 120 x squared e to the 2x, and then we have e to the minus 3x minus 3 e to the minus 3x 9 e to the minus 3x divided by 12 e to the minus x. It's the same, right? Okay, and guys, I'm not going to be computing it, okay? I'll just give you the value, which is 30x squared e to the x. Okay, and a3 prime is, I'll give you the value, which is 10x squared e to the 5x. Okay, I'll delete this out. So we know that a1 is integrate a1 prime dx plus c1. That would be integrate minus 40 x squared minus 40 x squared e to the 2x dx plus c1. And you need to do integration by parts, okay? You need to do integration by parts. I'm not going to do it, okay? I'm gonna give you the result, which is minus 20x squared minus 20x plus 10 e to the 2x plus c1. Okay, this you can integrate this function using integration by parts. Okay, and a2 is integrate 30x squared e to the x dx plus c2. And again, guys, you need to integrate this guy using integration by part as well. So the result is 30x squared minus 60x plus 60 plus c2. And a3 is integrate 10x squared e to the 5x dx plus c3. And this one is 2x squared minus 4 over 5 x plus 4 divided by 25 e to the 5x. Okay, oops, guys, sorry, I forgot one term here. Let me write it again. The a2 is x is 30x squared minus 60x plus 60 e to the x plus c2. Okay, and this is plus c3. Okay, once you have a1, a2, and a3, you know that the solution y is a1 y1, which is 1, plus a2 y2, which is e to the x, plus a3 y3, which is e to the minus 3x. Okay, just substitute them back into substitute a1, a2, and a3 into the solution. Okay, and I'll just write down the solution for you here, which is c1 plus c2 e to the x plus c3 e to the minus 3x plus 12x squared minus 84 divided by 5 x plus 1254 divided by 25 e to the 2x, and that is the simplified solution. Okay, and guys, that's it for the variation of parameters method. Okay, I hope it's not too hard for you. Okay, the method is quite easy, right? First, you need to get the roots when they are homogeneous, right? When they are homogeneous, so basically you let r be 0, right? And then you find the roots. After that, you have the solution, which is a1x a1 y1 plus a2 y2 plus blah blah blah, right? After that, you can get the system of linear equations, right? which is y1, y2, y3, y4, blah blah blah, y1 prime, y2 prime, y3 prime, y4 prime, blah 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 blah, right? Until y1 to the nth, y2 to the nth, blah 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 blah. And the column vector would be a1 prime, a2 prime, a3 prime, blah blah blah, until an prime, right? And the right hand side would be 0 0 0 0 0 0 0 0 0 and r, right? After that, you can use the theorem to find the a1 prime, a2 prime, a3 prime, right? And integrate those a's prime to get a, and after that you obtain the solution. One thing that you need to, you shouldn't remember, you must not remember, is that the coefficient of the highest order needs to be 1. Okay, and that's it for this video. We only have one chapter, we only have one section left, okay, which is Cauchy equation. Okay, it's gonna be the next section, and that's gonna be all for the midterm exam. Okay, so see you guys in the next video. Bye bye.